Good evening, everyone. Welcome to this edition of the education webinar on the topic impact of GenAI on higher education, which is going to be delivered by Professor Pankaj Jalote. Before we get into the webinar, I would like to give a glimpse of ACM India. ACM is the world's largest educational and scientific computing. And let me introduce myself. And I'm Chitra Babu, and I'm part of the Learning Initiatives Committee, as well as professor in the Department of Computer Science and Engineering at SSN College of Engineering, Chennai. Now back to introduction of ACM India. ACM is world's largest educational and scientific computing society with the mission of advancing computing as science and profession. It has 100,000 members approximately worldwide, in which more than 14,000 are in India. And ACM India chapters they form the backbone of the entire ACM India. So there are more than 200 student chapters and 25 professional chapters, and approximately around 30 ACMW chapters. And in the research angle, there are lots of initiatives. Along with the ACM India annual event, every year we organize this arts symposium, which gives an opportunity for the research scholars to present their work and get feedback from a wide audience from both academia and as well as industry. And actually some partial travel grants are given for attending conferences, and PhD clinic where the PhD scholars get feedback from lots of eminent people from different institutes as well as the industry. That's a very successful initiative. And as a continuation of that, Anveshan Setu, which gives an immersive experience. That is, the research scholars can go and spend some time with whomever they want in their place, that institute. And there are conferences, research level conferences, which are being organized like in the area of data science, COMED, and in the area of software engineering, ISEC. And in the education side, there are summer and winter schools which are organized every year in emerging topics. It will be a 2-week full-time course where the students are attending such schools and benefiting from that. And annually, we have a conference dedicated for education, which is Compute. We recently completed last year, 2023's Compute at IIIT Hyderabad. And then teaching partner program, which gives for the institutes, some external experts can co-teach that course. Partially, they will be teaching that course. That has been happening for the past 3 years. And CS Pachala is an initiative that inculcates computational thinking in schools. Then we also have eminent speaker program, and this kind of education webinars on every alternate month, industry webinars on every alternate month, industry boot camps, and mini graphs, which gives comprehensive coverage of a particular technical area. If someone wants to get into that area for doing research or something, these mini graphs are very useful. And of course, we have a very comprehensive digital library, which is available for everyone. And of course, the diversity, equity, and inclusion, this runs across the entire thing, all initiatives, whether it is conference or summer schools, everywhere it is there. And ACMW India has dedicated one dedicated summer school and winter school, and also it organizes hackathons and programming contests, which are exclusively for women students. Now, it is my pleasure and privilege to introduce today's speaker, Professor Pankaj Jalote. So he is a distinguished professor at IIIT-Delhi, of which he was the founding director. Prior to that, he has been a chair professor at IIT-Delhi, head of the Department of Computer Science and Engineering at IIT Kanpur, and an assistant professor at the University of Maryland at College Park. While he was on leave from academia, he was vice president at Infosys Technologies Limited for 2 years. and a visiting researcher at Microsoft Corporation, Redmond, for a year. He received his PhD from IIT Kanpur, MS from Pennsylvania State University, and PhD from University of Illinois at Urbana-Champaign. He is the author of 6 books, including the highly acclaimed CMM in Practice, which has been translated in Chinese, Japanese, Korean, etc., and the best-selling textbook, An Integrated Approach to Software Engineering. I had the pleasure of reading through his book. He has recently authored Building Research Universities in India. He writes regularly blogs in higher education in India and has written many opinion articles in leading newspapers. His research interests are in software engineering, open source software, AI for software engineering, and higher education. We're very happy to have you here, Professor. Over to you. I'll stop sharing.
Okay, so thanks, Chitra, thanks to you and ACM for inviting me for this talk come discussion. So I'm very pleased to be here. And so let me just share my screen and then we can get started from. Okay, so power. Okay, and all right, so I hope this is sort of clear. So I hope to discuss what I think are impact of Gen AI on higher education, right? So this is really more sharing of some thoughts. Nobody has a crystal ball. Nobody knows where this technology is heading and what impact it will have. But it's good to start discussing because across the world, I think people are really discussing this issue as to how things are going to change with Gen AI and how they're already changing. Okay, so we know that Gen AI is expected to impact all aspects of knowledge-based production, right? Not perhaps physical, but knowledge wherever knowledge is produced. Now, because of its generative capability is where things have gotten very, the impact is going to be on higher education. Because in higher education, we ask students to generate a lot of stuff, solutions to problems, reports, code, presentation, all that is knowledge that we ask them to generate. And now there is a tool available that can help them do it or can do it for them. So therefore, this generative capability is really disruptive. Okay. So we want to discuss today how it may impact higher education. So what I'll do is I'll discuss some different levels of higher education and then give some thoughts on how it may impact questions. And then last few slides, I will talk specifically some thoughts on computer science education. So this is not a research talk. It is just based on some personal views and thoughts and discussions with colleagues, right? So it is not a survey or a research kind of talk. So let's first focus on higher education. What does it do in the learning? So higher education, what does it do? It takes school graduates and produces graduates from higher education with some desired knowledge and skills and dispositions, right? All higher education programs do this. And so it's about higher education is about the students learning during this process. Teaching is the process of guiding them to learn. So with this in mind, the first question is, can Gen AI really impact learning? Can it make the learner, the student, faster? Can it make the student more efficient, or can it increase the capacity of the student, how much the student can learn? That's not clear. It's not going in the minds, right? So the mental capabilities are still the same. However, what Gen AI can impact is the goals of learning. So even though you learn so much, what do you learn? What to learn? That is definitely going to be impacted. And the overall education process. How do the students learn what we ask, what we hope they will learn? the process of teaching, etc. So we'll discuss some possibilities here, but I just want to scope it that it's about not the learning capability, etc., but essentially about what you're going to learn and how we are going to teach. So, it's good to look at higher education at different levels, because that's we have to see where it impacts and how it impacts, right? So we know higher education is about programs, BTech in various disciplines, BA in various disciplines, BSc, etc., etc., right? So what are the characteristics of a program? So for each program, implicit or explicitly stated, hopefully explicitly stated, there are some graduate attributes the program aims to develop. That is, it says, well, if you do this BTech in computer science, at the end you will have these capabilities, these knowledge, this thing. These are called graduate attributes, right? So that's the program. That's the goals of the program. Then the program itself is what? It's a network of courses. Every semester student does something, and over 4 years the student does some 40 odd courses, and these courses together ought to develop those graduate attributes. And then there is, of course, each course. We may have a course operating system, critical thinking, programming, whatever. Or, then the course design is really defined by the learning outcomes of that course, what the student learns in that course. And then we have teaching of that course to deliver those learning outcomes. So we as instructors are really dealing with course design and teaching of the course. But the higher education is a bigger stack. Now it's clear that GenAI is already impacting the teaching of the course. We'll discuss that. Its impact on the higher levels, it says course design, program, etc., that will come. But I'm hoping to have some discussion on that. So what I'll do is I'll quickly discuss these four, just a minute or so each of these. What do they mean? And then start discussing impact on it on the reverse order. Okay, so that's what we'll do. So graduate attributes is that the program has some general attributes it wants to develop, and it has some very specific computer science, electrical engineering attributes that it wants to develop. So together, these graduate attributes define the goals of the program. What is it that the students are learning, should be learning in this program? Okay. So just to give you an idea, so these are essentially statements about what a graduating student knows or understands or can do, right? So I've given some examples. These are all from AICT in the computer science. So graduate attributes, you can say for a BTech computer science graduate, at the end of the program, when the student graduates, the student has proficiency in writing programs, design algorithms and data structures for problems, understanding computing system at different levels, foundation principles, limits of computing, and analyze data, We can have some of these. And then there are also some general abilities, not which are across multiple disciplines. All BTechs we have it. Ability to solve problems and analyze them, work, use mathematical concepts, and ability to work in teams, communication, etc., etc. So these kinds of attributes, these are define the goals of a program. Okay, so that's what the goals are. That's the first level, highest level. Then the program itself is a network of credit units. We all know that. There are courses, there are internships, there may be projects in independent studies, etc. So the program, the curriculum, the aim is to develop those, to build those graduate attributes, right? So we know we have 8 semesters in a BTech program, only about 4, 5 courses, 5, 6 courses in a semester. So the main point is there's only so much a student can learn in a semester, and only that you can teach. Okay, just because new things have come, to add more does not help. You can only teach so much. And typically, program structure, there is some common core, we know that. There is some discipline core, computer science core. Then there may be some discipline electives, there may be some open electives, etc. Right? So this is how program is designed. Typically, that's the program. Okay, so this is the core from AICT for computer science I've taken, and these are very standard set of courses for computer science. Course design. So now we have a set of 30, 40 courses that the students are taking during their program. Each course is being taught by typically an instructor. Students enroll and we teach them. So course design, now course may have a title, operating system, data structures or algorithms, and then we have of course syllabus, etc. So the course design, typically a course has some learning outcomes. They are stated that at the end of the course, the student will learn this, and will have these skills. And then we design teaching and learning activities to help the student develop that. Lecturing is one of them. We may have tutorials, we may have labs, we may give practice assignments, etc. And very important, there is assessment and feedback. Okay, so while the student is learning, you have to assess the student, give feedback to student what he or she has learned, whether it's correct or not, and what are the mistakes he's making. That loop is extremely important, because otherwise the student can learn the wrong things and never correct. Okay, so these are three aspects of a course: learning outcomes, then what you teach, how you teaching act, and assessment. And the learning outcomes which drive the course, these are typically statements on understanding and skills of student at the end of the course. Right? So I've given some example here. For example, Intro to Programming course in IIIT-Delhi. These are some of the learning outcomes. Be fluent in the use of procedural statements. You effectively use built-in data structures. Be able to design and test Python code, etc. Right? The teaching and assessment, which is what we do, is that we give lectures, tutorials, assignments, etc. And assessment is the whole goal is to evaluate, measure, and document the academic progress, readiness, and progress of the student, learning progress. And common instruments that we use are we give assignments, we give projects, we give quizzes, tests, exams, etc. Right? I must say assignments and projects, etc., are very important for practicing and so on. Otherwise, tests and exam, there's only so much you can do. So assessments help students learn what was taught. It's an integral part of teaching, right? You cannot really have teaching without assessment. Okay, so this is the four levels that I briefly mentioned, right? We have the program, we have the graduate attributes, we have a program design as a set of courses, then we have a course design, and for each course we have learning outcomes and teaching. Okay, now let's just start the topic of discussion. How is Gen AI likely to affect? And we work backwards. Let's start with teaching, Gen AI and teaching. So first, every one of us is facing it, is the assessments have gotten harder. Now, how do you get students to do practice exercises with Gen AI being available? Right? That's the challenge. As I said, most of the time in most of our courses, we ask students to produce something, write an algorithm, write some code, prove something, write a report, make a presentation, etc. Right? So we ask them. Now, Gen AI can be used by students to do much of that. And we ask the students to do that not because we like to work them hard. That's a process of learning. That's a process of teaching. You learn something, then you practice it. And now if that instrument is compromised, how do we ensure learning by students? Okay, much of the higher education today is struggling with this aspect of it. We still continuing on what we our courses, regular courses, etc. And we faced immediately with this problem. How do I do assessment in my course? Okay. So what are the effective policies? What are effective approaches to do these kinds of assessments? That will evolve. Different people are trying different things. I know some people have said that, look, far more proctored environments will get far more important now for doing assignments, etc. So different people are trying different things, essentially teaching the same method that we want to do. We want the students to do some things, and we are asking them to now do it in some manner so the impact of Gen AI is minimized. That's what higher education is struggling with. Some people might be trying to, okay, you can use GenAI, but do this portion of it yourself or something like that. Like, it's an immediate problem. Already the impact is there. People are struggling. Teachers are struggling with it or facing this problem. On the other hand, GenAI can provide personalized assistance, which instructors and TAs cannot provide due to scale. If you have 100, 500 students, 200 students, you really cannot do effective TA work. You really cannot provide individual guidance and feedback individual level, right? So that is already the people are working on to use GenAI to provide personalized assistance, right? You may have heard Khan Academy has already started doing it for school students, and there is people are trying to look at whether we can have bot TAs and so on. So that can be the benefit of it. It can help instructors in preparing lectures, examples, assignments. So I know already some colleagues who are using it for preparing some notes or some slides and so on. Now, preparing assessments, I don't know what, I don't have experience or examples of how people may be using it to create new assignments. But clearly that can also be a possibility that you can use the GenAI capability. So teaching is getting affected. There is some direct impact on how we teach in terms of how we do assessments, but it can also help in doing some of our teaching work. Okay, so now let's go one level above, the learning outcomes, right, for courses. Right? We mentioned that each course has some learning outcomes, and the course is delivered to achieve them. Now, this is if we agree that GenAI is to be used as a tool by students. That is, it's not something to be avoided, but if GenAI is made available as a tool, then clearly some learning outcomes will become redundant, some new learning outcomes will have to be added. Right? So you're no longer saying that you do all these things yourself because these are to be developed. Now we're saying GenAI is a tool. So for example, in Intro to Programming, we can say simple, so students can write some code for functions, etc. Now, is it redundant? I'm not saying that it is redundant. I'm raising a question. Because if you say, hey, look, students, you can use GenAI for your assignments, then some things will become redundant. But the more challenging question is, what should be the new learning outcomes for a course? So if GenAI is available as a tool, some things will become redundant because students will use that tool to do it. Then what should be the new learning outcomes? Now the debate will have to reach there, in my view. We cannot ignore this tool. This tool will be there. Students will use it. It hasn't yet reached there because we're still struggling with the first portion of it. So the big challenge in Intro to Programming, if students can generate simple modules using GenAI, then what should the course now teach? Okay, we can discuss some of it later on. I'm not giving answers yet, but there is a question of what do you teach, and that's a big issue. Not this is just one example. There are going to be in each course that's going to happen. Okay, so the question comes, can a student, and then you have to ask, if some of the things go away, can a student learner really learn higher level concepts without being proficient in, let's say, basic programming of simple modules? So suppose you say, let's take away the simple module code writing, but then can the student write classes if he doesn't know how to write functions? Not clear, right? So it's a challenge. How do you design new set of learning outcomes if GenAI is supposed to be used as a tool? So I believe courses learning outcomes will evolve when GenAI is accepted as a tool, and I think they will evolve towards solving more complex problems and working at higher levels of abstraction. Again, Not fully clear how it will play out. I'll have some thoughts on it later on. But clearly, and also lower level things, some simple things will probably, uh, we may not develop the skills to do that. We may assume that these can be done through tools like this, but use them to work at higher levels. But what those will be is going to be a big challenge. And the question comes on program design. So that's the third level I'm saying. And so clearly new courses will have to be introduced, added to the programs, largely, I guess, as electives on this new technology and its capability. And that's beginning to happen. And we'll have some discussion on what will happen on the program design. If GenAI is made as a tool, course learning outcomes change, what will happen to the program? So my feeling is the core will become more compact, and then we'll have to think of what more to add. We'll have some thoughts on that for computer science in a moment. And finally, the highest level, the impact on graduate attributes. So the debate will reach here also. Once the impact on various aspects is clearer, what students can learn, how to teach, various courses, etc., then it will reach what do we want in graduate attributes. So it's not clear how graduate attributes will or should change. For example, should the graduate attributes now include something like proficient in the use of LLMs for various tasks? That is, we are expecting graduates in graduating in computer science, electrical, what have you, that they are proficient also with other things. They are proficient in the use of LLMs for various tasks in their discipline. Now, if this is added, it has major implications on design of curriculum, of courses, and all of these. Once you accept this as a graduate attribute, then everywhere we have to make sure that they are proficient in use of these. So that will have major implication when it reaches there. Okay. So now this as a general framework. So 3-4 levels, teaching of course learning outcomes, program, and the graduate attributes, what may happen. Now I just want to put in some of these thoughts in computer science. So some initial thoughts on the CS program, right? So these are just some thoughts, and not, I wouldn't say, nothing is proven. It's all some ideas. So we know in computer science programs, we have courses covering different aspects of computer science, right? Programming, data structures, algorithms, databases, you name it. And we are typically preparing students to take up industry career or research career. So our graduate attributes are defined that way. Capability in doing this, writing programs, etc., etc. So if you look more carefully, our focus is generally on helping students in 3 aspects. We're helping students understand some concepts. We are helping them gain some knowledge, conceptual knowledge about various things. And we are helping them build some skills. Right? So concepts are, they are fundamental, foundational to build a vocabulary of concepts, because you need to know some concept. Based on that, you learn something more. Right? That's how more complex things are learned. When you learn the concepts of underlying things, then you can use that understanding to build an understanding at the higher level. So typically, it is essentially providing a vocabulary for some things but it's fundamental to your learning progress. If you don't have this vocabulary, you can't learn this thing. If you don't know programming, you can't learn data structures. If you don't know arithmetic, you can't learn concepts of algebra. If you don't know algebra, you can't learn equations or differentially. So you build upon that. At the same time, so concepts are there. At the same time, we provide them knowledge. This is knowledge that we teach them that can be useful for students for problem solving. Right? So different types of algorithms, different query languages, different this, different that, lots of knowledge we provide. which student can use if faced with a problem. The student can pick and choose as to what knowledge is useful for that problem. And of course, skill is what student can do: design, code, test, build a system, write an operating system script, etc., etc. Right? So I'm saying that all our courses really focus on these three things in some way or the other. We're teaching them some concepts, is providing them with some knowledge, teaching them and hoping that they'll absorb it. And we give them through training and through exercises, we help build some skills so they get capabilities of doing things. So with LLMs now, once we accept that LLMs are there and that they are part of our larger system around us, then the balance between concept knowledge and skill will have to be changed, will definitely get impacted. So my thought is that concepts in each topic will remain very important, right? Because they provide the vocabulary for thinking and further learning and building knowledge. If you don't know algorithms, you don't know what order O means, big O notation means, if you don't know that there is a list and so on and so forth, you cannot build new knowledge on top of it. So concepts provide the vocabulary for thinking and of course further learning and building new knowledge. Okay, so computational thinking, programming concept of data structures, efficiency, correctness, concept of correctness, limits of computation, what can be done, what cannot be done, the concept of databases and that there is a query language, how the operating system works. So these are all concepts that students and that any professional understands, and then based on that you can learn more things. Once you understand operating systems, you can understand how networks work. Once you understand networks, you can understand how mail works and how web works. And concepts cannot be understood just in theoretical sense without having some examples, the knowledge, right? So you have to teach concepts, you have to teach some algorithms, and they have to know what those algorithms mean, how do they work, etc., complexity of it. So teaching of concepts and learning of concepts necessarily implies that you have to teach them, give them some knowledge about it, so they can learn those concepts. But with LLMs, some of the knowledge we teach for possible use, not for learning concepts, but use that, hey, look, learn these things also because you may use them. So learn 5 different algorithms, learn different types of SQL languages, how do you program different data structures after you've learned the concepts. How do you learn? How do you do that? All that is likely to become less relevant because that's available to students all the time. The students can learn, can get that knowledge to whenever they need to use it for the problem. Okay, so there is some concept and vocabulary, and then there is some knowledge which we are giving them for use. Okay, now I understand that this distinction is not hard and fast, and which portion of knowledge is important for concept and which is just something we are telling them so they have a larger range of tools available. That's qualitative thinking, but the point I'm making is that concept understanding of concept and conceptual thinking is going to remain important. However, the additional knowledge so they have a lot of knowledge base in their head to be used, that's probably going to become less important. Okay, so there is a possibility that some of the knowledge being taught may be omitted, while keeping those that develop conceptual understanding and building foundation, that has to be kept. So that's the first thing, that concept and knowledge, we have to see concepts remain important. Knowledge to some extent is important, but some of the knowledge that we currently impart may become less useful. And so So it may impact how much of concepts and knowledge we teach. Skills, some skills will definitely become irrelevant, but some new skills will become important. So for example, can you write SQL queries? I think it is already more or less irrelevant. It will become even more irrelevant perhaps. So clearly some skills are going to be less relevant, will become less relevant, but the new skills will become more important. What are those? Not very clear. So some higher level skills will become more relevant. It's not clear what those are. Some lower level skills will become irrelevant, is easier to look at and to think about and discuss with people and get an input. But what are those higher level skills? I think that will take some time to evolve. We have to see what, with this tool being available, what is it that what is it that engineers and professionals need to do? And that is, industry is also facing that, they're learning from it, and as that learning becomes clear, we'll have better idea of what higher level skills could be useful. But one thing this is my experience, I would like to share, that developing a useful software today is not about writing standalone programs, which is what we teach in CS education. Standalone data structures, program, this algorithm, this, bigger program, smaller program, largely standalone programs. The complexity today of shifting in useful programs is shifting to composing an application using, you have libraries, frameworks, databases, cloud, all kinds of stuff is available, which is realistically always used. And the complexity is shifting from writing standalone programs of good efficiency, etc., to this. And with LLMs available, again, writing an efficient algorithm program for an algorithm is probably already easily available. Probably design of an efficient algorithm can be done, but putting together these things will require different types of knowledge, more subtle knowledge, which uh, uh, and experience. So developing concepts, knowledge and skills on this will be, in my view, very much more important. So building a higher level skill, for which of course you'll need to develop concepts and knowledge, so people can build systems by using, of course you still have to write some portions of it, develop some portions of it, but you are working in a larger ecosystem where lots of things are available, and how do you do that is going to become more important in coming years. As I said, largely in CS education, we don't focus on that. We focus on standalone things, right? And this complexity is, to my mind, largely not addressed. So this will become important. But what other higher skills? In discussion, some people may have ideas as to what higher skills are, and we'll hear that. But I think with time we will sort of understand what those may be. Okay. Courses, that now just the last point, what kind of courses in CS programs? So if the core courses will focus mostly on knowledge and concepts and knowledge, which is important for that, there is likely to be more free hours. Now, what do you teach in those free hours? Okay. So clearly advanced courses on some topics is a possibility. More practice on applying concepts and leveraging available knowledge. Okay, I'm leaving all these question marks because I don't know what is, what, if we agree that some of these things can be reduced, then the question is, what do we teach? Again, similar to what are the high level knowledge and skills that we want to make. One thing is clear, there is going to be more focus on society, ethics, and profession. ACM curriculum has also this time emphasized that, as this is becoming more important. Well, how do you teach this is a challenge, but this will definitely become more important, and we'll probably see more things over there. And I think maybe more application courses for different domains. So computer science as its own discipline with only operating system networks, various courses about computer science. Maybe we'll see more about application in different domains. Biology, of course, is already there, but maybe, hey, look, business, it's already there somewhat, but we can talk in all kinds of different domains that where computation is important and where there is use of computation there. So I suspect that is another new set of courses that may come, which is providing broadening in a different way about the use of computing. So let me just end that higher education is about, as we all know, about learning and teaching, facilitating that learning. And impact of AI on learning by students, that's not clear whether anything is going to happen, but it will definitely impact teaching and it will impact the goals of learning. Teaching, it's already impacting. Goals of learning, it will impact. There is no doubt. How? We'll have to see. So it will affect learning outcomes, graduate attributes, will probably leading to redesign of programs and how it is there. As I said, it's very early days, just put in some thoughts there on how it may happen and some thoughts on CS programs, which is what I understand a little bit better. So that's the end of my talk. Thank you very much for your patience.